Our objective here is I can calculate molarity or volume for a dilute solution. So first, let's understand the principle of a dilution. If your iced tea tastes too strong, you could dilute it by adding more water. So when you add more water, you're changing the amount of water in your glass. You're also changing the amount of solution in your glass. You are changing the molarity or concentration of the solution. The only thing you're not changing by adding more water is the mass of the solute that's in your glass. So the solid part is still there, and you didn't remove any or add any. You only modified how much solvent or water was present. In chemistry, most chemicals are sold as pre-prepared, concentrated, really strong solutions, and then these are called stock solutions. In a classroom, however, you would never work with something as strong as, say, 12 molar hydrochloric acid, which is the strongest you can get it. You might work with a 1 molar or a 0.5 molar hydrochloric acid solution. And so in order to make solutions of these lower molarities, we have to use what's called a dilution calculation. So how do we figure out how to make those solutions that are weaker or diluted and safer to use? Well, first we'd have to do the calculation with the dilution formula. M1V1 equals M2V2. Make sure both your volume units match. It doesn't matter what they are as long as they're either both milliliters or they're both in liters. If one is in milliliters and the other is in liters, then change one to match the other. So now let's practice some sample calculations for a dilution. How much 12 molar hydrochloric acid is required to make 2.50 liters of a 0.50 molar solution? The first thing I want you to notice is that the 2.50 liter and the 0.500 molar are right next to each other. The first thing I want you to notice is that this 2.50 liters and this 0.500 molar solution, those go together. They're side by side. It's this volume of this molarity. So our equation is M1V1 equals M2V2. And so you're going to make these side-by-side numbers your M1. This is your M1 and this your V1. So my M1 is going to be 0.500 molar. My V1 is going to be that 2.50 liters. So as long as you get the two things side by side together, whether or not you make them your 1s or your 2s doesn't really matter. All right, so now let's look at the rest of the question to find the M2 and the V2. 12.0 molar hydrochloric acid is my M2, and therefore V2 is my X. I must be solving for that. And so when we solve for X, we do 0.5 times 2.50 divided by 12.0 molar. So we're going to divide both sides by 12.0 in our basic Algebra 1 skills. And we're going to get X is equal to 0.10, and that's going to be, since this was in liters, this is also going to be in liters. What volume of a 1.50 molar solution can be made using 0.0250 liters and 18.0 molar sulfuric acid? So again, these are side by side, so they go together. We're going to make those our M1 and our V1. So here's our equation, M1V1 equals M2V2. And so my M1 will make 18.0 molar, and my V1 is 0.0250 liters, equals, and then I can look at the rest of the question and get my M2. Here it is, 1.50 molar is my M2, and therefore I must be looking for V2. And it does say what volume. So yes, we're looking for V2. So we're going to do 18 times 0.025 and then divided by 1.50 in order to solve for X. So divide each side by 1.50. And so X is going to equal 0.3, and that's liters. It's the same volume unit as V1, that is V2. What is the molarity of a solution that is prepared by diluting 125 milliliters of a 6.0 molar stock solution to a final volume of 500 milliliters? So again, this volume and this molarity are side by side, so they're going to go together. So M1V1 equals M2V2. My M1 is 6.0 molar. My V1 is 125 milliliters, equals, and then if I look at the rest of the question, what is the molarity? So M2 is what I'm trying to solve for, and then it says we have a final volume of 500 milliliters, so that's my V2. Notice that my volume units are identical to each other, milliliters, milliliters, and so I don't need to convert one to match the other. But if they didn't match, you would need to make them match. So it'll be 6.0 times 125 divided by 500. Of course, the point of dividing by 500 is to isolate x. And so when we do this math here, we get x equals 1.50, and since we are solving for molarity, we'll put a capital M as our unit. If you need to make 30 milliliters of a 0.250 molar solution of NaCl from a solution that is 3.0 molar, what volume would you need? So first, the 30 milliliters goes with the 0.25 molar. So those are going to be my M1 and my V1. So we'll say 0.250 molar times 30 milliliters equals, as I read the rest of the question, here's the other molarity, so that's M2. And that means I must be solving for V2, which we are. What is the volume that's needed? So it's going to be 0.250 times 30, and then divided by 3.0. And algebraically, I'll just show that. So we're going to get an x is equal to 2.50, and that's going to be milliliters since we were looking for volume, and V1 is in milliliters.